So we're going to take and this is like an elementary school type of demo. You may have seen this before. Maybe you didn't know how to explain it. Okay, but here it is. I'm taking a glass, okay, a little tumbler. I'm not sure why they call it a tumbler. Does it tumble down? It's going to break. But they call it like a big. So I'm just going to put some regular old water in here. Most of water is pretty old if you think about it. Was it just me today? No. All right, so I got water that's just basically covering the top of that tumbler. And I'm just going to take a cardboard top and put a top on there. Bring that up. And it's not filled to the top. I can do this better. All those people that serve drinks out there, I'm pretty impressed how you can walk a drink over and not spill any. Okay. This is going well. Okay, one more time. Okay, so this is pretty filled to the top.
That's not Bogowski in the service industry.
Yeah. Invert. Oh boy. And then, of course, let go.
Whoa.
So why does that stay that way? Well, how much water can be temporarily? How much water can be suspended? It's not funny if it breaks down. How much water can be suspended in a column? About 30 feet.
Oh, yeah.
Evangelista Torricelli, come on. How much feet did I have there? Now that was a bad example. We'll do that again. That was too much fun. I think my cardboard had a little issue.
Yeah, I think it like got soggy.
Yeah, what happens is if there's air that gets behind it, okay, it's a problem. So that was a, so let me take a piece here, the same thing. This is gonna work better, I think. Okay, so how much water can be supported by atmospheric pressure? 30 feet. So I would have to have a tumbler, okay, over 30 feet for this not to work. I just can't hold it. Okay? Now, this is really important. That looked like a lot of weight of water, and water's pretty heavy when you think about it. Okay? So if I can support, does it matter what size column it is if pressure is force over an area? No, it doesn't. It's just I can't hold a big, huge a column. But I can hold a small amount of water there. So even though the first one dropped because air got underneath my warped cardboard, which is pretty funny anyway, all right, that works pretty well, okay? And it's pretty amazing that atmospheric pressure hitting the bottom of the carbon can support actually 30 feet of water no matter what size, the pressure over area. Now, if the tube is bigger, if the circumference of my tumbler was bigger and I could hold it, it would still work. I would need more force to hold more water, but because I have more area with a bigger piece of cardboard, wouldn't that be the same ratio? Of course. Now, if 30 feet can be supported of water in a tumbler, think how much force that little foot or foot and a half or half a foot of water is nothing compared to how much more it can hold, correct? So if I take another tumbler, this one is easier for me to hold. That other one's concave. I shouldn't even work with that anymore. Okay, and I take this tumbler, fill it with water, same idea. Okay, let it overflow. I don't want to get anything underneath. And I invert it again. Same demo. Now, this is the cool part, I think. I know you're afraid of me because of the water spilling, but I've got about 6 inches of water. There's 29 and a half more feet of water that air can support, correct? So this is nothing. This is nothing. In fact, if I move this carefully, probably the air pressure with the surface tension of water would hold this.
What the heck? Okay.
Wait a minute.
It's not going to hold it for long. Okay. Okay. So it's pretty amazing how that can work.
Wait, why doesn't it do that if you just flip it over regularly?
Oh, because it's too much force. You break the surface tension of the water. You got to do it gently. Also, I had some help. It's called I had a screen in there.
Okay, that's what I thought.
Actually, the screen fell off. It's a great magic trick because the screen just fell off. So it's awesome. I was like, you see the screen? Like, it's not even there. It just fell off. Some other class I can't do this with. All right. So, yeah, rock on. But yeah, I had a screen. Now, with the screen, there's no way I'm going to continue this video or this lesson thinking that works. You guys are going to go home and spill water all over the place. Besides, the screen is kind of cool because by having the cross section here, that's just enough of opening or covering with the surface tension of water, the H bonding, to hold it together. So without the screen, it would not work. But that was kind of awesome that I went to show that I shouldn't have said anything. I should have stopped the video there. Okay, the screen fell off when I poured it. That usually doesn't happen. So I gotta actually glue that for my next.